Hello everyone and welcome back to CSE Interview Prep. So today we are going to discuss a problem from the topic trees which is most frequently asked in the interviews. So let's start. I am talking about the problem lowest common ancestor of a binary tree. So what is LCA? LCA of the two nodes in the binary tree is the common ancestor which is the lowest enough of the two nodes where either of the nodes can be the LCA of the given nodes. So the definition sounds quite confusing. So we can just categorize in the parts. So first point, LCA is common ancestor of two nodes, which is lowest. Second part, either of the given node can be the LCA. Okay, so let's explain with the example. So we can see that we have provided a binary tree here with node values as 1, 2, 3, 4, 5, and we are going to find the LCA of the given two nodes. Okay, so here LCA of 4 and 5 is 2, LCA of 4 and 3 is 1, LCA of 2 and 5 is 2. Let's see how we are achieving these results. So let's consider the first case where the P I am considering as the first node and Q I am considering as the second node. So I need to find the lowest common ancestor of these two nodes. So we can see these are the common ancestors of P and Q. You can see here. But the lowest common is 2. So let's see, so here we find the 2 here. That means what condition we get here? That means to say if the left subtree is not null and right subtree is not null, will return root for the first case. For second case, if we are considering my P as 4 and Q as 3, so here the common ancestor is 1. Again we are seeing in the left subtree of the root and right subtree of the root. So kind of the same condition we can see further for the proper explanation. This is my LCA. Now let's see for the third case, which is the LCA of 2 and 5. So this is my Q and this is my P. So let's focus on this third point. Either of the given nodes can be the LCA. So this is the part of the definition. So we can say the common ancestor of these two nodes is 2. So from this what we are encountering, that means if P is equal to root or Q is equal to root, that means we are the LCA is root itself. So returning root. So what's the problem is? The problem is that we have been given a two node values like P and Q and a tree, binary tree. We have to find the lowest common ancestor of these two nodes. So let's see how we are going to approach this problem. So in order to start the problem, what we can see, this is my node which is the root value, this is my LST, this is my RST. What I will do, firstly I will check my root is null or not. So if root is null, I will return null. Okay, otherwise I will find the LCA in the left subtree. That means, no, one case before finding the left subtree, what I will do, I will check if root equal to P, any of the node value is equal to root or not, I will return root is the LCA for the second case. What is the third case? I will check if these two conditions are not true, I will check in the left subtree and the right subtree. So I will find whether my left node is present or not. So I will find in the LCA of left subtree, right, equal to LCA of RST. I will tell you what these two things are, LST and RST. So we can see if any of the left node or the right node is null, the either one is the LCA. So if left is null, if left is not null, we have seen one case where left is not null and right is not null. So root will be the LCA. Then what if the left is null or the right is null? We will see one with the example. So let's see in the given example where my left subtree is totally null. So let's see, I have given P and Q as the 6 and 7. So how we are going to find the lowest common ancestor of 6 and 7, which is 5. We know that, but we have to find with the algorithm. So firstly, we are going to check root is null. No. So this condition gets false. What I am going to check again, if root is equal to P or root is equal to 2, no, that is also false. I am going to find the left subtree, LCA in the left subtree, and LCA in the left subtree is null totally. So if left is null, what will be the case? I am proceeding forward, which is root equal to root dot right. I am proceeding forward means I am going to find the right subtree. I am going to return the right subtree, which is the right node, which is 3. For this, I am going to check the left part and the right part again, unless and until we are going to find any of the condition where the left subtree is not null and right subtree is not null, where we are returning root, either or root is equal to p or root equal to q. So at this point also my left subtree is null, so I'm going to check with the right subtree. In the right subtree, the root is provided as 5. Again, I am going to check for the left subtree and the right subtree. So left subtree is p. If I am going for the left subtree and making this as root, so root is equal to p. So I am going to return 6 is my LC. But for the right part, root is 7. Root dot right is 7, which is the LCA for this part if I am going this right subtree. So we are checking if these two subtrees are not null, then root is the LC. If P and Q are the LST and the RST respectively of the root is the LCA. Now we found the LCA as 5 for the right part. Okay, so consider for this thing, left is null and right is not null. Left subtree is null and right is not null. That means we are going to return right. That means we can say here, if left is not equal to null for one case and right not equal to null, we are going to return root. If root dot left is equal to null, then we are going to return right. Otherwise, we are going to return left. Sorry for the space which is not there, but I assure you, you will get proper code in the next slide. So just please bear with me. So in this way, we are going to find the right subtree, the LCA in the right subtree here, which is 5. So for this case also, we are going to return 5, and for the overall case, we are going to return 5 as the LCA. So let's see the overall code for the lowest common ancestor of a binary tree. So here we have provided a root node of the given tree and 2 nodes for which the lowest common ancestor to be found. So here we are considering all the cases. So if the root is null, we are going to return null. So let's say for the case where the root belongs to either the first node or the second node, we are going to return root. Otherwise, I am going to find the left subtree and the right subtree. If the left subtree is null, so we are going to check for the right subtree, which we have already discussed. But if both the left subtree and right subtree is not null, so we are going to return root here. If left subtree is null, we are going to return right, so that it can perform check in the right side and in the right side. And if right subtree is null, we have to check for the left subtree, and we will return left node for that case. The time complexity for this algorithm is the number of nodes which we have traversed, which is order of n, because we need to traverse almost all nodes to check the lowest common ancestor between P and Q. So that's all from my side.